Hello, grade 9 students. Still, we are on the topic graphs of quadratic functions, and I think this is part 5. Okay, so in this topic, we will learn how to graph a quadratic function by using a table. We'll learn the axis of symmetry, y-intercept, and vertex. Also, the maximum and minimum value. And we will also learn how to solve real-world example quadratic equations in the real world. So, content standards interpret parts of an expression such as terms, factors, and coefficients. Compare properties of two functions, each represented in a different way, algebraically, graphically, numerically, tables, or by verbal descriptions. Mathematical practices make sense of problems and persevere in solving them. In previous lessons, you identified and manipulated graphs of functions. This time, we'll learn how to graph quadratic functions and find and interpret the maximum and minimum values of a quadratic function. So these are the new vocabulary for this topic: quadratic function, quadratic term, linear term, constant term, parabola, axis of symmetry, vertex, maximum value, minimum value. Okay, graph f of x equals x squared plus 3x minus 1 by making a table of values. Choose integer values for x and evaluate the function for each value. Graph the resulting coordinate first and connect the points with a smooth curve called the parabola. So assign values of x, start with -3, -2, -1, 0, 1. Substitute it to x squared plus 3x minus 1, and that will be the value of f of x or y. So for -3, -1. If x -2, y is -3. If x -1, -3 ang y. If x 0, f of x is -1. If x is 1, y is 3. So with the corresponding ordered pairs. So plot it on the Cartesian plane, connecting the points with a smooth curve called the parabola. So this is the graph of f of x equals x squared plus 3x minus 1. Which graph is the graph of f of x equals 2x squared plus 3x plus 2? The answer is C. Okay, by using table of values of x with the corresponding values of y, you will come up with this graph. Letter C. Let us now consider the graph of y equals ax squared plus bx plus c, where a is not equal to 0. The y-intercept is a. Okay, when we're solving for the y-intercept, we're going to let x equal 0. So we have here a times 0 squared plus b times 0 plus c, or c. So the y-intercept can be written as c. Okay. And the equation of the axis of symmetry, x is equal to negative b over 2a, or simply the h, the value of h in the vertex, which is negative b over 2a. And the x-coordinate of the vertex is negative b over 2a. The axis of symmetry, x equals h, or x equals negative b over 2a. Y-intercept is the point of intersection between the parabola and the y-axis. Yes. So consider the quadratic function f of x equals 2 minus 4x plus x squared. Find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. Begin by rearranging terms of the function so that the quadratic term is first, the linear term is second, and the constant term is last. Then identify a, b, and c. So what is a? 1, b, negative 4, and c is 2. After that, we can now determine the value of y-intercept, which is 2. So when the quadratic function is in its general form, we can immediately determine its y-intercept, the value of c here, which is 2. Now, use a and b to find the equation of the axis of symmetry. Negative b over x equals negative b over 2a is the equation for the axis of symmetry. This is actually a line. So, negative a is 1, b is negative 4, so substitute. Negative times negative 4 over 2 times 1, so positive 2. X equals 2 is the axis of symmetry of the given quadratic function. So the y-intercept is 2, the equation of the axis of symmetry is x equals 2. The vertex, therefore the x-coordinate of the vertex is 2. And in our previous lesson, you know how to solve the y-coordinate of the vertex, which can be solved using the formula 4ac minus b squared over 4a. Or you can simply rewrite the equation to its vertex form, right? Now, consider the quadratic function f of x equals 2 minus 4x plus x squared. Make a table of values that includes the vertex. Choose some values for x that are less than 2 and some that are greater than 2. This ensures that points of each side of the axis of symmetry are graphed. So from the table of values, we have located the vertex, which is 2, negative 2. Okay, 2, negative 2 is the vertex. Therefore, h is 2, k is negative 2. Consider the quadratic function f of x equals 2 minus 4x plus x squared. Use the information from parts a and b to graph the function. Now, graph the vertex and y-intercept. Then graph the points from your table, connecting them with a smooth curve. As a check, draw the axis of symmetry x equals 2 as a dashed line. The graph of the function should be symmetrical about this line. Yan. The vertex is at 2, negative 2. X equals 2 is the axis of symmetry, with the y-intercept 0, positive 2. Okay? So that's the answer for example 2. Check your progress. Consider the quadratic function f of x equals 3 minus 6x plus x squared. Find the y-intercept, the equation of the axis of symmetry, and x-coordinate of the vertex. So, for the y-intercept, it's equal to c. The equation of the axis of symmetry equals x equals negative b over 2a, or x equals h. And the x-coordinate of the vertex is equal to negative b over 2a. Wait, x-coordinate of the vertex is also the negative b over 2a. Excuse me. So therefore, the y-intercept is C3. Axis of symmetry is x equals negative b over 2a, negative 6 over 6, so 1, negative 1 or 3. Wait, negative b over 2a. Wait. Excuse me again. Sorry for the interruption. So what's your answer? The answer is C. So the y-intercept is equal to C, which is 3. Axis of symmetry is x equals 3. Negative b over 2a. Yes. And also, the x-coordinate of the vertex is also 3. Next, how about this? Consider the quadratic function f of x equals 3 minus 6x plus x squared. Make a table of values that includes the vertex. Okay, what's the vertex for this? Using our previous knowledge, negative 6 over 2, positive 3. Okay, so 3. How about f of x? How about f of x? Yes, if this is 3. 3 minus 18, negative 15 plus 9, 6. 3, 6. So it's A. I think it's A. Wait. I think the answer is D. 3, negative 6. Negative 6 pala yung f of x. Yes, 3 minus 18, negative 15. Negative 15 plus 9 is negative. Yes, negative 6, not positive 6. Alright, D. Next, consider the quadratic function f of x equals 3 minus 6x plus x squared. Use the information from parts A and B to graph the function. Okay. The vertex is, I think this is from the previous example. The vertex is 3, negative 6. 3, negative 6. B, it cannot be an answer. This is a parabola that opens upward because A is positive. Alright, so, and then axis of symmetry is x equals 3. A, C, and D are just the same. But from the graph, from the table of values, we have 0, 3. Does it pass to 0, 3? 1, negative 2. 0, 3, yes. Okay, only A passes through 0, 3, which is the y-intercept. So the answer is A. Next, another maximum and minimum value. The graph of f of x equals ax squared plus bx plus c, where a is not equal to 0, opens up and has a minimum value when a is greater than 0. Okay, you know that when a is positive, it opens upward and has a minimum value because the vertex is up is in the down part. And then when a is less than 0 or negative, it opens down and has a maximum value. This one. So a is negative, it opens downward. If a is positive, it opens downward. And the y-coordinate is the minimum value. And yes, the y-coordinate is the maximum value for parabola that opens downward. Consider the function f of x equals negative x squared plus 2x plus 3. Determine the function has a maximum or minimum value. Yes, if a is negative, therefore the parabola opens downward, so it has a maximum value. Yes, it has a maximum value. Next, state the maximum or minimum value of the function. Since yes, what's the answer? If this has a maximum value, what is the maximum value of this function? The maximum value of this function is the y-coordinate of the y-coordinate of the vertex. The x-coordinate of the vertex is 1 from the formula negative b over 2a. Negative 2 times 2 times negative 1, so positive 1. So to find the y-coordinate of the vertex by evaluating the function for x equals 1, substitute 1 here. So negative 1 plus 2, 1 plus 3, 4. I think it's 4. So the maximum value of the function is 4. Alright. So that is the y-coordinate of the vertex is the maximum value. Maximum value of the vertex. I mean the function. While the x-coordinate of the vertex actually the axis of symmetry. Next, consider the function negative x squared plus 2x plus 3. State the domain in range. Of course, when you say domain of quadratic function, all set of all real numbers. But when you say range, it's actually y is less than or equal to k, or less than or equal if a is negative. If a is positive, greater than or y is greater than or equal to k. So the domain is all real numbers. The range is all real numbers less than or equal to the maximum value. And what is the maximum value here? Which is actually the y coordinate of the vertex 4. So f of x or y is less than or equal to 4 is the maximum value. Is the range, I should say. So the range is y is less than or equal to 4. Yun. Domain all real numbers. Range f of x is less than or equal to 4. Check your progress. Consider the function f of x equals x squared plus 4x minus 1. Determine whether the function has a maximum or minimum value. Of course, a is positive, so it opens upwards, so it has a minimum value. Consider the function f of x equals x squared plus 4x minus 1. What is the maximum or minimum value of the function? Okay, so since it opens upward, it has a minimum value, so the minimum value is the y coordinate of the vertex. What is the vertex? Negative b over 2a, negative 4 over 2, negative 2 is the x coordinate of the vertex. Now to solve for y, substitute negative 2 here. Negative 2 squared is 4 plus negative 8, negative 4 minus negative 5. I think it's negative 5. A, yes. That is the minimum value of the function. How about here? What are the domain and range of this function? All real numbers, domain. Okay. So C is not considered as an answer. And then the range is, since this is A is positive, it opens upward, it's greater than. Yes, greater than. So B and C are not. B and C and D cannot be answered. So A, I think, is the correct answer. F of x equals f of x greater than or equal to negative 5 is the range of the function, while the domain all real numbers. So let us now apply our knowledge in quadratic equations in the real world. Can be applied through economics. With this problem, a souvenir shop sells about 200 coffee mugs each month for $6 each. The shop owner estimates that for each 50 cents or $0.50 increase in the price, he will sell about 10 fewer coffee mugs per month. How much should the owner charge for each mug in order to maximize the monthly income from their sales? So income equals number of mugs times price. It's the formula for income. Let x the number of $0.50 price increases, and let L of x equal the income as a function of x. So we have here our equation. L of x equals 200 minus 10x times 6 plus 0.50x. So income is the number of mugs times price per mug. So income is actually our L of x, the function. The number of mugs is 200 minus 10x times the price per mug is 6 plus 0.50x. Solving for the function by the FOIL method, we have here yon 1200 plus 100x minus 60x minus 5x squared. Simplify 1200 plus 40x minus 5x squared. Now write in ax squared plus bx plus c form. It's equivalent to negative 5x squared plus 40x plus 1200. Then after that, L of x is quadratic function with a negative 5, b 40, and c equals 1200. Since a is less than 0, therefore this function opens downward, so it has a maximum value at the vertex of the graph. So use the formula to find the x coordinate of the vertex. So we're trying to find the maximum value here, so we're trying to solve for the value of k. So let's first solve for the h, negative b over 2a. Negative 40 over 2 times negative 5 is 4. This means that the shop should make 4 price increases of $0.50 to maximize their income. So the mug price should be $6 plus $0.50 times 4, or equivalent to $8. That's the answer, $8. Yeah. Another same problem but different given. Souvenir shop sells about 200 coffee mugs each month for $6 each. The shop owner estimates that for each $0.50 increase in the price, he will sell about 10 fewer coffee mugs per month. What is the maximum monthly income the owner can expect to make from these items? So to determine the maximum income, find the maximum value of the function by evaluating L of x for x equals 4. So the function is L of x equals negative 5x squared plus 40x plus 1200. And then substitute x by 4. Negative 5 times 4 squared plus 40 times 4 plus 1200, which is equal to $1,280. That is now the maximum monthly income the owner can expect to make from these items. $1,280. Now let us check your progress. Sports team sells about 100 coupon bands for $30 each during their annual fundraiser. They estimate that for each $0.50 decrease in the price, they will sell about 10 more coupon bands. How much should they charge for each book in order to maximize the income from their sales? Is it A, $29.50? Is it B, $20? Is it C, $17.50, or D, $15? Okay. So I will tell the answer now, and I think you will show to me the solution from our previous example. The answer is $17.50. Another, a sports team sells about 100 coupon bands for $30 each during their annual fundraiser. They estimate that for each $0.50 decrease in the price, they will sell about 10 more coupon bands. What is the maximum income the team can expect to make from these items? So this is just like in our example 4. So I need your solution, and this is the answer. C, $6,125. This ends our topic, graphs of quadratic functions. I hope you learned a lot. How to learn graphing quadratic functions. How to learn graphs of quadratic functions, because I made 5 video lessons for this. This is part 5 actually. So I hope you learned many things in graphing quadratic functions. So goodbye, see you next time.